My name is Chavala, and this is my partner, Mr. Teka. And here we are about to introduce our third experiment, which is titled Light Activated Alarm Circuit. We are about to start our first stage, which is our prototype. Thank you. As we all know, this is our alarm activated circuit, and which comprises or consists of multiple components. We have resistors, capacitors, transistors, as well as a LDR, which will be used to detect light. So I'm gonna do the connection on my breadboard. Come down. So I'm gonna use this first low as my 9-volt positive terminal. So I'm gonna place my first component, which will be my 1 kilo resistor. Okay, and I'm gonna connect my other resistor, which is in series with it. This is my 4K7. Okay, as we connect down, I'm gonna place my LDR in series with the resistor K2, 47K, and I'm gonna connect the last part to the ground. Okay, so I'm going to put my PNP transistor. Okay, I'll be using this as my connecting wires. My emitter will be connected to the 9 volts. And my base will intersect the resistors. Okay. So I'm going to connect my emitter to another resistor, which is 2K2, my resistor 8, 2K2. There you are. So my collector will be connected to 2K2. Okay. I'm gonna put my 10 kilo resistor, which will be connected to the grounds. Which will connect to the grounds. Okay, so I'm done with the first upper part. I'm going to add another NPN transistor. Okay, my emitter, will be connected to the ground, and my base, which is this one here, is going to be connected to our 2K2 resistor. Okay, so my collector will be connected to my base, to my emitter of my NPN transistor, which I'm going to replace here. collector will be connected to my emitter. This emitter is also connected to this other emitter of my NPN. Put in this emitter here. I want to use this line to join these two together because these lines are connected in parallel to these other ones. So here, and from here I'll connect my other emitter. Because there is a break between these two, I'm going to connect another connecting wire to make sure that the current which is flowing from this side also flows to the other side. Okay, good. So now, as I have connected this, my base of this transistor is going to be connected to this other capacitor. I'll connect two capacitors over here, which will be these two. So this base is going to be connected to this other terminal of a positive terminal of our capacitor. Okay. And this other terminal, our base, will be connected to the other terminal of our capacitor. So now they are intertwined to each other like this. So as I connect this emitter, okay, just a minute. So I'm going to connect my collector to my capacitor. Okay. So this capacitor is connected, the transistor is connected in series with the resistor K1, 1K, which will be connected to our my hands are slippery. Which will be connected to our 9 volts terminal. And it's also connected to our 10 kilo ohms, okay, which is also connected to our 9 volts. I'll connect another 10 ohm. Okay, and lastly, we're using our 330 kilo ohms to limit the current that goes through to the speaker. Okay. Because of this black which is here, I'm going to use a connecting wire to connect the two sides together. Okay, voila. And now this terminal of my collector will be placed between this capacitor over here. Okay, now that I've completed this, I have to insert our speaker. So this is our complete connection, as you can see from our start to the end. So at this point my partner is gonna come to verify it's working. If it's working, you hear the sound coming out from there. Out. Lastly, let me connect my battery. This is our 9. Okay. So to check if it's working properly.
Friend is finished the prototype. Now I'm putting the light towards the light dependent resistor. So as you know how the light dependent resistor works, as light intensity increases, the resistance decreases. Therefore, we should hear the sound there. When there's no light, there's no sound. But when sound is there, when light is there, we hear the sound from the speaker. So now I'm putting light towards our light dependent resistor. Right, you are hearing the sound, right? This shows the presence of light. So our circuit is working. Our circuit is functioning. When I remove the light, then the sound stops. By this, I thank you. Okay, so now we've finished our prototype and we've seen that our circuit is functioning. So we've achieved what we wanted. So now I want to do the circuit explanation. So in spite of using this prototype, I'm going to use the circuit on the screen because this one is a little bit complicated than this one. So the title of my circuit is Light Activated Alarm Circuit, or they can call it Light Activated Sound Generator, because at the last we noted that we should hear a sound when we put a light on our light dependent resistor. Okay, so this is where the LDR is on our circuit. As light intensity increases, the resistance of the light dependent resistor decreases. Then, as you see, this LDR, it forms a voltage divider network with this R9. So the voltage divider is the one that is going to control the voltage at the base of the transistor Q1. So when insufficient light falls on this LDR, there's going to be a voltage drop at the base of the transistor. That means, in other words, we can say Q1 is not conducting. So Q1 is off. But when sufficient or enough light intensity falls on the light dependent resistor, Q1 is going to conduct. When Q1 conducts, it is going to influence Q2 to conduct also. As Q2 conducts, okay, at first I didn't tell you. So as you see, our circuit is divided into two parts. This first part is for light detection and switching. So the LDR here is the one that is going to detect light. Then this Q2 here is going to act for switching. And this other part is this other part is the light generation section. This is the sound generation section. So this is the side where sound is going to be generated from this loudspeaker. Okay, I was explaining Q2 here. So when sufficient light is on our LDR, we say that Q1 is going to conduct. When Q1 conduct, it is going to influence Q2 to conduct. So Q2 is going to power this side, the other part of the circuit. So this is how Q2 works as a switch. Okay, so now I'm moving to another part, which I tell you that this is the sound generation section. So when this side is powered by this, when this right side is powered by this left side, this side is going to act as a self-oscillating circuit. This transistor Q3 and this transistor Q4 are going to turn on and to turn off very fast at a frequency determined by the capacitor C1 and C2 and their associated resistors. As Q1, as Q3 and Q4 turn on and off very fast, they are going to produce an electrical pulse. So that electrical pulse is the one that is going to drive our speaker, producing a buzzing sound. So this is how our circuit works. So in conclusion, we can now say in the presence of light, there's going to be sound, and in the absence of light, there is no sound. So with this, I thank you.